Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you should have x minus 9 times x minus 1. For the math knowledge question, we have students that can make an A, a B, a C, or a D in their art class. And so the fraction amount for each student, or for each grade, is going to add up to 1. So for the A's, there were a fifth of them that made A's, there were a fourth that made B's, and then half made C's. And they don't tell us the fraction amount that made D's, they just say 10 of them made D's. So we need to figure out what fraction goes with those 10. So the common denominator is going to be a 20 here. And so 1/5 is going to become 4/20. 1/4 is going to become 5 over 20. And 1/2 is going to become 10 over 20. And if you add those together, you get 19 over 20 plus D equals 1. So if you subtract, D is going to be 1/20. So 10 students is 1/20 of the school population. So 1/20 of 200 would equal 10. So if you wanted to make an equation there, 1/20 times the total number of students equals 10. So then just multiply by 20 on both sides of your equation, and that would give you your total is 200. Okay, so we are looking at lesson 12 today. We're going to be looking at proving lines parallel. So hopefully you'll understand how to prove lines that are parallel. So the first postulate we're going to look at is the converse of the corresponding angles postulate. If you have two lines that are cut by transversal and the corresponding angles are congruent, then the lines are parallel. So if the measure of angle 1 is congruent to the measure of angle 2, those are corresponding angles, then you have two lines that are parallel. So we want to prove that lines M and N are parallel. So if you look here, based on the information that they give us, angles 1 and angles 2 both measure 32 degrees. We have congruent corresponding angles. Therefore, by postulate 12, lines M and N are parallel. So that's how you could prove that the two lines are parallel. The next theorem we're looking at is theorem 12.1, the converse of the alternate interior angles theorem. So if angles 1 and 2 are congruent, then these two lines are parallel. So we want to prove that lines J and K are parallel. So the first thing that we have to do is to get a pair of congruent alternate interior angles. So we know that the measure of angle 1 plus the measure of angle 2 has to equal 180 because they are a linear pair or because they're supplementary. So because they are a linear pair. So since angle 1 equals 123, the measure of angle 2 is going to equal 57 degrees. From there, That means that the measure of angle 2 is equal to the measure of angle 3, which means that angle 2 is congruent to angle 3. By theorem 12.1, lines J and K are parallel because we have congruent alternate interior angles. So that's one way you could write it out. You need the same information, but it doesn't really matter how you actually write it out. Okay? So now we're going to look at the next theorem, theorem 12.2, the converse of the alternate exterior angles theorem. So you can refer to it as theorem 12.2 or the converse of the alternate exterior angles theorem. I am writing theorem 12.1 here and postulate 12 because those are much shorter than the names of the theorems. But if you don't know the number whenever you're doing your homework, you can just name what it is. It's a converse of your alternate exterior angles theorem or interior or whatever it is. So this one's very similar. If you have congruent alternate exterior angles, then your lines are going to be parallel. So let's look here. We want to identify both pairs of alternate exterior angles. So we have two pairs, angle 1 and angle 7. And then the other one is angle 4 and angle 6. So that would be the answer for part A. For part B, we want to prove that lines P and Q are parallel. So the measure of angle 4 is equal to the measure of angle 6. Well, they're actually congruent because of the arc marks. So we know they're congruent. We don't even have to say they're equal because they didn't give us any numbers. Therefore, so this is the mathematical symbol for therefore. So if you would like to use it instead of having to write out therefore, you can. Therefore, by theorem 12.2, lines P and Q, that's supposed to be a Q, are congruent because there are congruent alternate exterior angles. So that's how you can prove that one. These are all basically the same thing, just with different theorems, slightly different angles, but it's the basic concept every time. So looking at this next theorem, 12.3, if two lines are cut by a transversal and the same side interior angles are supplementary, then the lines are parallel. So if the measure of angle 1 plus angle 2 equals 180, then the two lines are parallel. This is the only one that if they're not going to be equal, they're going to be supplementary. And that's because your same side interior angles are supplementary, not congruent when you have parallel lines. So let's look at this one. We want to identify both pairs of same side interior angles. So you're going to have angle 2 and angle 5, and angle 3 and angle 8. So that would be the first thing. Now for part B. We want to use the converse of the same side interior angles theorem to prove that they are parallel. And the reason they specify, right now they tell us that we have alternate interior angles congruent, and they don't want us to use those. So we can say first off, based on the arc marks in the diagram, or in the picture, the measure of angle 3 is congruent to the measure of angle 5. And then we know that the measure of angle 5 plus the measure of angle 8 equals 180 because they are a linear pair. Then we can use substitution. We can plug the measure of angle 3 in here for the measure of angle 5. So the measure of angle 3 plus the measure of angle 8 is equal to 180. Since we have same side, interior angles 3 and 8 that are supplementary, because 3 and 8 add up to 180. By theorem 12.3, lines S and T are parallel. So that could be how you explain that one. Okay, so now we're going to look at another example. In San Francisco, California, Columbus Avenue crosses Stockton, Powell, Mason, and Taylor Streets as shown on the map. Columbus Avenue makes a 40-degree angle with each of these streets. What geometric term best describes Columbus Avenue? Well, it is a transversal. Now we want to prove that Powell, Mason, and Taylor Streets are all parallel to each other. So I'm not going to write this one out, I'm just going to explain it. So the 2 or the 3, we're looking at all 3. The 3 40-degree angles at the intersection of Powell, Mason, and Taylor and Columbus Avenue means that, well, those are all corresponding angles. And so since they are congruent corresponding angles, that means that those 3 streets have to be congruent to each other by postulate 12. And so you could do the same thing for 2 of them and then say the third one has to be parallel because it's parallel to the same line if you wanted to, but that's not really necessary. But they all 3 have congruent corresponding angles, and so that's why they are parallel to each other. And then Stockton is parallel to the other 3 streets because it also has a corresponding angle that is 40 degrees. And so for it, it's going to be parallel to the other 3 streets because of its corresponding congruent angle. Alright, so let's see if y'all can do these practice problems by yourself, and then we'll go over them. So we want to prove that lines A and B are parallel. So for this one, the measure of angle 1 is equal to the measure of angle 2 because they're both equal to 148. So measure of angle 1 is congruent to the measure of angle 2. Angles 1 and 2 are corresponding angles. So since we have congruent corresponding angles, we can use postulate 12 to tell us that lines A and B are parallel. For part B, prove that lines U and V are parallel. So since I'm going to add another angle here so that I can refer to it. So since angles 2 and 3 are supplementary because they are a linear pair. That means that angle 2 plus angle 3 has to equal 180 degrees. So 111 plus angle 3 has to equal 180 degrees. So that means that angle 3 is going to have to equal 69 degrees. Since angle 1 equals 69 degrees, that means that angle 1 and angle 3 are congruent to each other. And since angles 1 and angles 3 are congruent alternate interior angles, that means that by theorem 12.1, lines U and V are parallel. So hopefully you had something along those lines for those two practice problems. For these next two, identify both pairs of alternate exterior angles and prove the lines parallel. So y'all try that by yourself, and then I'll go over it. So identify both pairs of alternate exterior angles. That's going to be angle 1 and angle 7, and angle 4 and angle 6. So given that angle 1 and 7 are congruent, we want to prove our lines are parallel. So if these two are congruent, then we have congruent alternate exterior angles. And we can use theorem 12.2 to prove that lines M and N are parallel. So that one's not a terribly difficult one because I told you that your angles are congruent. Looking at this one, we want to identify both pairs of same side interior angles and then prove that the lines are parallel. So y'all try that one by yourself and then I'll go over it. So your same side interior angles would be angles 2 and angles 5, and angles 3 and angles 8. Then given that angle 2 is congruent to angle 6, use theorem 12.3 to prove that they are parallel. So angle 5 and angle 6 are a linear pair, so they are supplementary. They equal 180 degrees. And then angle 2 is congruent to angle 6. So using substitution, we had angle 5 plus angle 6 equaled 180, and angle 2 equaled angle 6. You can plug in here to make angle 5 plus angle 2 equal 180. And so angle 2 and angle 5 are same side interior angles, and they are supplementary. So since we have supplementary same side interior angles, by theorem 12.3, lines M and N have to be parallel. Okay, so now we're going to look at two more. So y'all try these by yourself, and then we'll go over them. So for the first one, Spear Boulevard is a transversal. Now we want to prove that Fox, Elati, and Delaware Streets are all parallel to one another. So there are angles marked at Fox Street and Elati Street that are congruent and corresponding. So by postulate 12, Fox Street and Elati Street are parallel. By the same argument, Elati and Delaware Street are parallel. And so since you have two lines that are parallel to the same line, that are also parallel to each other, all three streets are parallel to each other. And that's from a previous postulate. I don't remember the exact number of it, but it's the transitivity of parallelism. I don't remember which one that was. So that's how you can explain those. Or you could do like we did on the other one. They all three have corresponding congruent angles, so they all three have to be parallel. All right, so this is our challenge question. So y'all see if you can write a paragraph to explain how we know that they're congruent, or not congruent, parallel, and then I'll go over it. So for this one, it is given that the measure of angle B is 55 degrees here, and this angle here is 125. the measure of angle here has to be supplementary to this 125. So the measure of angle CED has to equal 125. It has to add up with 125 to equal 180. So if you subtract, this angle would have to be 150. And then we have corresponding congruent angles. So that means that these two lines are parallel. That would be by postulate 12. You could also do it by by theorem 12.3 by using these same side interior angles that are supplementary to make the lines parallel. So you could do it either way. They didn't specify, so you just have to make sure to include all your information. So hopefully that helps you a little bit with lesson 12. Your homework is 1 through 30, so make sure that y'all do those tonight so we can go over any questions you have tomorrow.